Good morning, my YouTube viewers. It's Crystal here, and what I'm going to do in this video is I'm going to cover the assessment of the Alison course, Probability and Chance in Mathematics. And in my two previous videos were Module 1 and Module 2 of the same course. Now, when we go over the assessment questions, you'll notice that the assessment questions are not the same as what was covered in Module 1 and Module 2. But fortunately, I was able to take the questions and convert them to Python, and I've also converted them to Excel, so I'll be making videos on Excel as well. So there's about somewhere in the neighborhood of 20 questions. So I'm just going to go ahead and go through the questions and work through them in Python so you can get an idea of how to do it. And this is a good way to perform exercises in probabilities. So we have a manufacturer of metal pistons finds that on average 12% of his pistons are rejected because they are either oversized or undersized. What is the probability that a batch of 10 pistons will contain no more than 2 rejects? So first thing we're going to do is we're going to use Python scientific library being SciPy. So from SciPy.stats, import binom, and that's your binomial distribution. So N is the total of pistons equals 10, and P is the probability of rejection, which is 0.12. And we're going to compute the probability of 0, 1, or 2 rejects. So probability equals binom.cdf brackets 2, N, P, and the probability that the 10 pistons will contain no more than 2 rejects is 0.8913. So we have the next question. It says a random variable x follows the normal distribution with mean x equals 60 and that's x bar. I think that's an x bar equals 60 and standard deviation of sigma equals 5. Find x is less than or equal to 60. So again, we're going to use Python scientific library being SciPy. So it's from SciPy.stats so import SciPy.stats as stats. So we're going to have our given values of mu, that's your mean, is 60. Sigma is your standard deviation, is 5. And x is the value that we're computing probability for, is 68. So we compute the probability of x is less than or equal to 68. Probability equals stats.norm.cdf brackets x, mu, sigma. And then we print the probability, and it's 0.9452. So we've got another question. There are 16 girls and 8 boys in a class. Half of these 24 students study French. The probability that a randomly selected girl studies French is 1.5 times the probability that a randomly selected boy studies French. How many of the boys in the class study French? So you've got your total students equals 24. French students equals total students floor 2. So what it's going to do, it's going to take the total students and it's going to divide it by 2, but it's just going to give you the nearest whole number, which in this instance, the nearest whole number is going to be 12. But if it had been 20, total students had been 25, the nearest whole number would be 12 as well. So girls equals 16, boys equals 8. So we're going to define the probability variables. P, boy French, equals French students divided by brackets 1.5 times girls, plus boys. And we're going to compute the number of boys studying French. Boys studying French equals boys times P boy French. And so the number of boys studying French is 3. So we have the next question. 2 events A and B are such that PA equals 0.2, comma, PA, I guess that's going to be intersect B equals 0.15, and PA apostrophe intersect 3 equals 0.6. Find the probability that neither A nor B happens, brackets, find PA union B, and then we have our given probabilities. So PA equals 0.2, PA intersect equals 0.15, PA complement enter B complement equals 0.6. And then we compute A is the complement, PA union B equals 1 minus PA complement enter B complement. Then we compute PA union B. PA union B complement equals 1 minus PA union B. And then we print that out, and it's the probability that neither A nor B happens is 0.6. So we have the next question. A bag contains 10 yellow, 6 green, and 4 blue discs. 1 disc is drawn at random from the bag and not replaced. Another disc is then drawn at random from the bag. Find the probability that both discs are of the same color. So we have the total disc is 20. And then the probabilities for the same color is yellow prob equals brackets 10 divided by total disc, brackets times, brackets 9 divided by total disc minus 1. And green prob equals brackets 6 divided by total disc, brackets times, brackets 5 divided by total disc minus 1. And then blue prob equals brackets 4 divided by total disc, brackets times, brackets 3 divided by total disc minus 1. And now we compute total probability. Same color prob equals yellow prob plus green prob plus blue prob. And the answer is 0.3474. So now we have the next question. In a class of 30 students, 20 study physics, 6 study biology, and 4 study both physics and biology. A student is selected at random from this class. Find the probability that this student studies physics. So we have the total students equals 30, physics students equals 20. And then we compute the probability. Probability equals physics students divided by total students. And the answer to that is 0.6667. So we have the next question. A radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 kilometers per hour and a standard deviation of 10 kilometers per hour. What is the probability that a car picked at random is traveling at more than 100 kilometers per hour? So we have, we're going to use Python Scientific Library SciPy. So we're going to import scipy.stats as stats. We're going to have our given values is the mean or the mu is 90, the standard deviation or sigma is 10, and x is the value that we are computing for is 100. So we're going to compute the probability of x is greater than 100 using the survival function 1 minus CDF. So probability equals stats.norm.sf brackets x, mu, sigma. And the answer to that is 0.1587. So the next question we have is, the length of an instrument produced by machine has a normal distribution with a mean of 12 months and standard deviation of 2 months. Find the probability that an instrument produced by this machine will last between 7 and 12 months. So we're going to use Python Scientific Library being SciPy. So import scipy.stats as stats. We have our given values of your mean lifespan, or mu, is 12. Your standard deviation, or sigma, is 2. Your lower bound, x1, is 7. And your upper bound, x2, is 12. So we're going to compute the cumulative probabilities. Prob x2 equals stats.norm.cdf brackets x2, mu, sigma. That's for your upper bound. And then prob x1 equals stats.norm.cdf x1, mu, sigma. That's your lower bound. So we're going to compute the probability for the range. So probability equals prob x2 minus prob x1, and the value that you're left with is 0.4938. So the next question we have is, a certain type of archery competition, Laura hits the target with an average of 2 out of every 3 shots. The shots are independent of each other. During one competition, she has 10 shots at the target. Find the probability that Laura hits the target exactly 9 times. So we're going to use Python Scientific Library SciPy. So from scipy.stats, import binomial. So we have our given values. Is the number of shots is n, is 10. The successful hits is k, is 9. And the probability of hitting the target is p, and it's 2 divided by 3. So we're going to compute the binomial probability. Probability equals binom.pmath, that's probability math function, brackets k, n, p. And the answer is 0.867. So we have another question. It says, for a certain type of computers, the length of time between charges of the battery is normally distributed with a mean of 50 hours and a standard deviation of 15 hours. John owns one of these computers and wants to know the probability that the length of time will be between 50 and 70 hours. So we have the mean battery life, mu, is 50. The standard deviation, sigma, is 15. The lower bound, x1, is 50. And the upper bound, x2, is 70. So we compute the cumulative probabilities. So prob x2 equals stats.norm.cdf brackets x2, mu, sigma. Prob x1 equals stats.norm.cdf brackets x1, mu, sigma. And then so we compute the probability for the range. Probability equals prob x2 minus prob x1. And then you're left with a value of 0.4088. So the next question we have is, a bag A contains 4 blue and 5 yellow counters. Bag B contains 2 blue and 6 yellow counters. A counter is picked at random from bag A and placed in bag B. A counter is then picked at random from bag B. Find the probability that the counter picked from bag B is yellow. So what we're going to do is we're going to define our probabilities. So P move yellow equals 5 divided by 9. And P pick yellow given yellow is 7 divided by 10. So you have P move blue equals 4 divided by 9. And P pick yellow given blue equals 6 divided by 10. So now what we're going to do is we're going to compute the total probability. P pick yellow equals brackets P pick yellow given yellow times P move yellow brackets plus brackets P pick yellow given blue plus P move blue. And so you've got an answer of 0.6556. So we have the next question. Is a die is tossed 3 times. What is the probability of no 5s turning up? Choose 1. So the probability of not rolling 5 in one toss is P no 5 equals 5 divided by 6. And then probability of not rolling a 5 in 3 tosses. Probability equals P no 5 to the power of 3. So you get an answer of 0.5787. So we have the next question. A random variable x follows a normal distribution with mean x equals 60 and standard deviation sigma equals 5. Find P brackets 52 is less than or equal to x is less than or equal to 60. So we're going to use a SciPy scientific library to find the answer to this question. So import scipy.stats as stats. So we have our given values of the mean or mu is 60. The standard deviation or sigma is 5. The lower bound or x1 is 52, and the upper bound x2 is 68. So we compute the cumulative probabilities. Prob x2 equals stats.norm.cdf brackets x2 comma mu comma sigma. Prob x1 equals stats.norm.cdf brackets x1 comma mu comma sigma. And then so we compute the probability for the range. So probability equals prob x2 minus prob x1. And you have an answer of 0.8904. So we have another question. A certain basketball player scores 60% of the free throw shots she attempts. During a particular game, she gets 6 free throws. What is the probability that she scores on exactly 4 of the 6 shots? So we want to use Python scientific library being SciPy. So from scipy.stats, import binom. And then we're going to have our given values of the total free throws being N is 6. Successful shots being K is 4, and probability of scoring is P is 0.6. So we're going to compute the binomial probability. Probability equals binom.pmf brackets 4, n, p, and we're left with an answer of 0.3110. So we have the next question is, a marksman finds that on average he hits a target 4 times out of 5. If he fires 4 shots, what is the probability that he has more than 2 hits? So what you want to do is you want to use Python scientific library SciPy from scipy.stats, import binom. We have our given values of total shots is N is 4. With the probability of hitting the target is P is 0.8. So we compute the probability of Px is greater than 2 equals Px equals 3 plus Px equals 4. So probability equals binom.pmf brackets 3 comma n comma p plus binom.pmf brackets 4 comma n comma p, and you have an answer of 0.8192. So we have our last question, and I said it was around about 20 questions that I did because some of the questions were fill in the blanks. So I only did the questions that were actually, you could compute it with Python. So a random variable x follows a normal distribution with mean x equals 60 and a standard deviation sigma equals 5. Find p. X is less than or equal to 52 and is less than or equal to 68. So we're going to import scipy.stats as stats. That's Python scientific library. We're going to have given values. Mu, or the mean, is 60. Sigma, or the standard deviation, is 5. X1, or the lower bound, is 52. And X2, or the upper bound, is 68. So we're going to compute the cumulative probabilities. Prob X2 equals stats.norm.cdf brackets X2, comma mu, comma sigma. And then prob X1 equals stats.norm.cdf brackets X1, comma mu, comma sigma. We're going to compute the probability for the range. Probability equals prob X2 minus prob X1. And you have an answer of 0.8904. And so what that does is that completes all of the questions that were questions that you had to work out in the assessment. And what I did was I converted them to Python. I think what they wanted you to do in the assessment was to actually calculate them by hand, because in the assessment they did actually give you formulas that you could use to calculate them by hand. But I was in a hurry. I didn't have time to calculate everything by hand, but I think that's what they wanted you to do. And as you can see, if you've watched the video for Module 1 and the video for Module 2, you'll see that the material that was covered in the assessment was not necessarily what was covered in Module 1 and 2. But you can use these questions as exercises. It's good practice questions, you know. So you can use them to learn about probability and chance in mathematics. So that concludes this video, and that concludes the videos for this course in Python. So if you like my video, please like and subscribe. The next series of videos I'm going to be making is going to be in Excel. So if you use Excel, then that certainly would be a good batch of videos for you to watch. So thank you again for watching my video. I look forward to communicating with you in the next one.